All right, good morning, you guys. Today we're going to be going over 4.2. I'll be doing a few of the actual checkup questions with you. And through the file transfer window, I did share a copy of the PowerPoint. So if you would like to save that and print that out to write on as we go through today, that would be fine. Otherwise, you can just take notes on paper too. That's always acceptable. So just know that I did share that with you. So if you didn't save it when it first came through, the way that you can get to a copy of it is by going to Window and then Show File Transfer Library. And in there, if you click on the name of the file, then it will allow you to save it by clicking on the old school floppy disk symbol. Okay, so let's go ahead and we're going to jump right into 4.2. I know that your test is on Friday and we still have not had a chance to cover 4.3, so I will tell you how we're going to handle that towards the end of the session today, because I don't want to leave you hanging with any of the sections that we haven't covered together. So here's our essential question for today, and you'll have a really good idea how to answer this by the end of the session. It says, when looking at the right and left side of a problem, how do you pick which side of the problem to start solving when dealing with an identity? Now you probably already have a good idea of which side to pick, but I just want to really clarify for you today how you know and why you pick which side. So 4.2 is a lot of deriving formulas. You may be thinking, oh my gosh, why are they showing me all of these steps when I can just give you the formula and we can use the formula? It's really important, especially in Pre-Calc, that you understand where the formulas come from, and that's really what's happening in 4.2. They're really just trying to show you where they come from, and once we get past 4.2, all you have to do is use them at that point. So bear with me today as we do a little bit of proving some formulas, and we'll do some of your checkup problems together. And then at the end of the session, when we move into 4.3, it's really, we move away from the proving aspect and we move into just using the formulas. So we're going to start, yes, and we are in week 12. So this will be our week 12 Dropbox. You can use other trig identities to prove the one that you're trying to prove. That's really helpful for us. So do you guys still have a copy of the formulas that I shared last week? I also emailed them out too. Do we have those handy? If not, I can resend at the end of the session, but I want you to keep that printed out, keep that with your notes. So we're going to start today by jumping right into cofunctions. These two are considered cofunctions of each other, sine and cosine. Let me remind you why. So let's jump in and look at the graph. So if here's my sine graph, sine starts at 0, peaks at pi over 2, comes back down, still has a full period of 2 pi. For cosine, cosine is the same graph except it starts at 1, cuts through pi over 2, but it still has a period of 2 pi. The reason that these are considered cofunctions is because they are basically the exact same graph. They're just shifted from one another. How much are they shifted? By about pi halves. Well, exactly pi halves. So if I take my red function and I cut out this first portion to pi halves, look what I have. Look at my graph. It's the cosine graph. Do you guys see that? Right here. So that's all that they're saying with the word cofunction. Cofunction means they are actually the same function, just slightly translated, or we call it a shift, shifted from one another. So that's all that that big scary word means. They are the same function, just shifted from one another. So sine and cosine, they're shifted by pi over 2. If you cut off that part of the graph, they become the same graph. Are we okay with that terminology, cofunction? That was the very beginning of 4.2. So again, I kind of went over this earlier, but 4.2, there's a strong focus on the derivation of the formulas, meaning how they derived them, how they come across these formulas. Once we get past 4.2, all we have to be able to do is use them. So keep that cheat sheet handy that I sent you. So we're going to jump right into the checkup. We're going to do a couple of them together, a couple of the proofs. So we're going to start with first making sure that you guys understand the cheat sheet that I sent you. So when this says the sum or difference of two angles, this is part of that cheat sheet right here. If I give you this, sine of A plus B, you're going to be looking on your cheat sheet for this one right here. And I don't want this plus or minus to fool you. This plus or minus just means if you have a plus sign in the problem, like I do right here, you're going to be using the top portion. So when I come across my right-hand side, I'm going to say sine A cosine B plus cosine A sine B. So that's how we're supposed to be reading this. So when it says to use the plus sign, that means we're going to be using the top version. That's why I'm clarifying today. So that would be sine A cosine B plus cosine A sine B. If, changing highlighters here, if my problem has a minus in it, then we're going to use the minus portion, meaning this bottom portion. So if it said sine A minus B, then when I come back here and I'm reading my formula, sine A minus B, I have to come to the bottom. Sine A cosine B minus cosine A sine B. Are we okay with that idea of how to use this chart? They're just giving you two formulas in one to sort of save space. That way it all fit on one page. I'm just making sure we understood. If it's a plus or a minus, you have to use that portion of the formula. Okay. Same with when they give you the double angles. Those are pretty straightforward. Pythagorean identities, those are also straightforward. Yeah, all the other ones, you use them as is. So that only weird section was the last one for the sum and the difference formulas. I just kind of wanted to cover that with you guys. So here we go. We're going to start with problem number 3, and we want to derive the identity. So let me give you just a second to copy that onto your paper. So again, this is number 3 from the 4.2 checkup. 4.2 loves for us to derive our formulas. So when I'm starting and I see my problem, and Dakota kind of already answered this before I even asked the question, how do I know which side to start with? Do I start with my left or do I start with my right? And the answer is I'm going to start with my right. Yes. Why am I starting with the right? Because it is the more complicated side. When we're proving identities and we're deriving identities, we're always going to start with the more complicated side. Because from there, once we write out what we know and we try to simplify, our simplified answer should equal the simplified version on the other side. So we're going to start with the more complicated side. So when I'm looking at my right-hand side, I'm asking myself, is there a way that I can rewrite any of this? Do I have an identity for any of these items? So when I'm looking at it, I want to check out my chart, and I want to see, what do I have a formula for? I have a formula for cosine A minus B, and I have a formula for cosine A plus B. So let's check and go back to that formula page real fast. So that would be this middle one right here. I have a formula when it's A plus B, and I have a formula when it's A minus B. So I'm going to fill in, instead of saying A plus B, I'm going to fill it in with this. Instead of saying A minus B, I'm going to fill it in with this. So let's do that together. I still have that one half way out in front there. I'll worry about that later. So let's work on this A minus B first. That's going to give us cosine A cosine B plus sine A sine B. Any questions about step number 1? So we should be okay just checking this out and looking up the formula. So now let's work on the second portion. The second portion is cosine A plus B. So that gives us cosine A cosine B minus sine A sine B. I'm going to highlight something very important for us here. Change colors. It's right here. It is asking us to subtract these two from one another. So that means in between these two, I need to be subtracting them. The reason I'm going to put that in parentheses, can actually one of you type in, why do I put that in parentheses? Because what am I going to have to do if it's minus this whole thing? Good job, Nicole. We're going to distribute it. So when it's minus a whole set of terms, I'm going to have to distribute. So let's distribute and see what we have now. So I would have a minus cosine A cosine B plus a sine B. Because two negatives made a positive right there. Let's drop down this left side of my equation. That way I can see what exactly I'm working with here. I still have that 1/2 way out in front, and we'll deal with that at the end. So what do you guys think my next step would be? Because this is kind of a mess, right? Or at least it looks sort of like a mess. Exactly. There's a lot of different ways to say it. So we can say we're combining like terms. We can say that we're simplifying. You know, lots of ways to say the same thing. So if you guys on your paper, go ahead and write your next step and then see if your work matches mine. So I had a cosine A cosine B minus a cosine A cosine B. So cosine A cosine B minus cosine A cosine B goes away. Now let's combine these two. I have a sine A sine B plus sine A sine B. So that's the same as saying a 1 plus a 1 gives me a 2. Sine A sine B. And then way out in front, I did have that 1/2. And again, we could say that we are combining like terms here. So my 1/2 and my 2 are going to cross off. So that leaves me sine A sine B, which is what I was originally trying to show that it equaled. How did we do? Did that one go okay? Questions on any of those steps? Let me know. Sometimes it's like once you see the steps, you're like, oh, okay, I did know how to do that. I think that a lot of these problems just look very intimidating at first, but once you kind of write out what you know, it's really just sort of algebra. Even though it looks complicated, it really is just combining some like terms in here, even though they look crazy with all these trig functions. This part of the chart that I sent you guys is going to come in so helpful for the 4.2 section, because what we're going to be able to do is we'll be able to look up a radian, like 3 pi over 4, and find out what the cosine value is at that point. This is going to come in handy for our next couple examples. So keep this chart handy and we're going to come back and refer to it. So let's try this one. Find the exact value of sine 75. This means you cannot give me the decimal point answer. That's not what it's looking for. So we're not even going to use a calculator for this. So let's look back at our chart. Do I have a sine 75 in degrees? Is there a 75 on here? Oh, there's not a 75. So I have to fix that. Can you guys think of another way that I could get to the number 75 using numbers that I do know on my chart? Because we could say 60 plus 15, but there's not a 15, so I can't use that one. So Nicole got it, and there's more than one right answer too. Okay, we're going to say sine 30 plus 45. Now let's talk about why we're doing it this way. The reason that I'm doing it this way is because we have a formula when it's the sign of adding two angles. We have a formula for that. So we have to put it in a kind of a form that I have a formula for. So for instance, if I go back, I go a couple slides here. See, I have a formula when I have a sine 30 plus a 45. I have a formula of how I can write that out. So that's why I'm picking to rewrite it as the addition of two angles. Does that make sense, Dakota? Because I have a formula I can use for that. Okay, so let's come here and let's write in our formula. So this would be sine 30 cosine 45 plus cosine 30 sine 45. So again, the reason that I'm choosing to write it as the addition of two angles is because I have a formula for that. Now from here, I'm going to use my handy dandy chart and look up what each of these are. So sine 30, let's look at my chart. Sine of 30 is 1/2. Is everybody okay with using their chart? Do we understand how to use it? So sine of 30 is 1/2. So I'm going to come back and I'm going to put in a 1/2. Cosine of 45, let's go back and take a peek. So cosine, here's 45, I get root 2 over 2. Plus cosine 30, so use your chart, I get root 3 over 2. And sine of 45 is root 2 over 2. Is everybody okay with how I got each of those four numbers? Okay, fabulous. So from here, we're just going to simplify. So let's multiply across the top, across the bottom, and see what we get. I'm going to get root 2 over 4 plus, I'm actually going to leave this alone, root 3 root 2 over 4. The reason that I'm doing that is because we want to be able to factor out as much as possible, meaning I'm looking for a common term up here. Do you guys see a common term? So instead of me writing this as root 6, if I leave this as a root 3 root 2, I have a common term going on here. I have this. So I can pull out the root 2 on top. I can put the whole thing over 4 first of all, right? Because since it's addition and I have a common denominator, I can write the 4. So if I pull out a root 2, what am I going to have left? I'll have a 1 plus a root 3. So when they say find the exact value, this is what they are referring to. They want it in the root form, not a decimal form, because I know in 2 seconds we can all type in sine 75 and get a decimal answer. We didn't even need 4.2 to be able to do a decimal answer. 4.2 is all about how to find exact values. Smiley face, did we do okay on this one? Questions, comments, concerns? Okay, great. So let's try again, but this time instead of giving it to you in degree form, let me give it to you in radical form. So I put another chart in here so I can go back. So this is very similar to problem number 4 on your checkup, and we're going to find the exact value of sine 7 pi over 12. So when I look on my chart, I do not have a sine of 7 pi over 12, right? There's no 7 pi over 12. I don't have that option. So we have to ask ourselves, what two fractions can I add together to get 7 pi over 12? Now that's kind of a little more complicated because none of these are in 12ths right now. You guys agree? But we just can think of common fractions for a minute. So like if I have 1/3, 1/3 is the same as 4 over 12. If I have a 1/2, that's the same as 6 over 12. So what I'm looking for is I need two fractions that are going to add to give us, oops, I went the wrong way, 7 pi over 12. So when I think 7, I think of 1 plus 6, or I think of 3 plus 4. Do you guys see how I'm doing my fractions in my head? I haven't really changed the fractions yet. So I think 1 plus 6 gives me 7, or 3 plus 4 gives me 7. Let's see which of these are on my graph. Do I know is there a 1/12 on my graph? No, can't use that one. What would 3/12 be? 3/12 is the same as 1/4. I have a 1/4 on my graph, right there. And 4/12 is the same as 1/3. Do I have a 1/3 on my graph? I do. So that's how I help myself decide what my fraction is going to be. Which fraction am I going to use? You're going to take your whole fraction and kind of break it down. How can I get to 7 again? 1 plus 6 or 3 plus 4. Which ones of these were on my graph? Only this option was on my graph. Does that help a little bit? Only those options were on my graph, on my chart. Because there isn't a pi/12. There isn't one. I couldn't use that way. So let's come back over here. So we're going to say, instead of doing 7 pi/12, we're going to do 3 pi/12 plus 4 pi/12. Which when I reduce, that's pi/4 and pi/3. Are you guys okay? You with me now? They just take some practice. So since it's an addition problem, let's write out what my formula is going to be. My formula is going to be sine. Oops, I put 3 pi/12. I could say, sorry, hang on. I don't think I reduced them the first time I put them in here. I'm going to start over because the first time I wrote it out, I didn't reduce them. So then I'm going to write them in the reduced form this time. Now I'm going to look on my chart, check out what each of those are, and fill them in. So I'm going to get √3/2 times √2/2 plus the 1/2 times √2/2. So again, my new denominator is going to be a 4. And on top, I can pull out a √2. So I will be left with a √3 plus 1. And that'll be your answer. Okay, so where are we at? Did that one make a little bit more sense? Questions, comments, concerns? These are the questions from the checkup. I'm not sure if I'm pretty sure they're the same as the quiz, but I haven't looked at it to double check. You can turn off the recording at the end of the session and I'll go take a peek for you. How about that? Okay, great. Okay, so here again is our chart. So I put another chart in here for us to use before our next example. So here we go. This is very similar to problem number 4 on the checkup. It says find the exact value of cosecant 195. So let's write that one down and solve this one together. So on our chart, there is no cosecant 195, but what could I add together to get us to a 195? And great point, Dakota. We're going to get there in just a second. So looking at our chart actually does have a cosecant. Is everybody okay with that? Our chart has a cosecant. So right now, let's leave it as a cosecant, but we'll talk about how to get our final answer in a moment. Can we think about what two numbers could add together to give us a 195 that are on our chart here? So what kind of degrees could I add together to get a 195? Good job. Good job. So there's two ways to do this one. And I want you guys to understand that there's not just going to be one right way. There could be more than one right way. So one way would be 150 and 45, because that would certainly get us there. Another way could be 135 plus 60. You guys okay with those two options? There's two different ways to add together to get a 195. Everybody okay with that? And it doesn't matter which one you pick, we're all going to get the same answer in the long run, which is pretty cool. Here's the other cool thing. If you could come up with a number minus a number that gives you 195, that would work as well, because we have a formula for when it's a subtraction problem. So there's lots and lots of ways to do these. The key is just picking a combination that gets you there, and our final answers will look the same. So I'm going to pick, let's do 50 and 145. 150 and 45. But again, do it the other way if you would like to. So here's the thing. I don't have a formula for cosecant. I don't have one that adds two things together for cosecant. But we know that cosecant is the same as 1 over sine. Everybody okay with that? So what I'm going to do is I'm going to pretend that it's a sine, solve, solve, solve like it's a sine, and then I'm going to do the reciprocal of my final answer. And that's going to be my answer. So that's the easiest way. You could do 1 over sine right now, but then you're working with fractions the entire time. So the best way to do it when you have a cosecant or a secant function is solve it just as if it's a regular sine and then reciprocal your answer. So let's all pretend that this is the sine of 150 plus 45. And then again, we'll just remember to reciprocal our final answer. So here we go. We're going to get sine 150 times sine 45 plus cosine 150 sine 45. So when I look on my chart, I'm going to get 1/2 root 2 over 2. And then cosine 150 is negative root 3 over 2 and root 2 over 2. So on the bottom, I'm going to have a 4. And on the top, they both have a root 2 in common, so I'm going to factor out a root 2, and I'm going to be left with 1 minus root 3. Now, remember, that's not my answer. This would be my answer if my function was asking me for sine. Since it's asking me for cosecant, the way we would write our final answer is with the reciprocal. I'm going to just turn it upside down. So 4 over root 2 times 1 minus root 3. And if you use the other option, you know, the 160 plus 30, you're going to get the same final answer. That's what's so cool about it. Oh, or 165 plus 30, one of those. Okay. You guys get the idea? How do we do? So if they give you one of your alternate trig functions, you're going to solve it just like it's a regular one and then just take the reciprocal of your answer. Yes, no, maybe so? Do we do okay? Sorry, it would have been 135 and 60. Well, thank you very much, Dakota. I'm glad that we are doing these weekly sessions. I definitely think that they're helpful. Math is just not something that you want to be teaching yourself most of the time. It's just difficult, so I agree. The online lessons are not always the best. Okay, let's try this one. This is 8A from your checkup. This time we're going to write this product as a sum. So what this means is this time I'm going to take a peek at my identities, and I'm probably going to be working one of them backwards. Oh no, I'm not. I'm just looking at my sum and product formulas. I don't think I gave a picture of those, but if you guys have your sheet handy, what we're looking for is when I have a cosine multiplied by a sine. So we should be in the upper right corner of our trig identity paper where I have a cosine multiplied by a sine. Can you guys give me a smiley face if you found that on your chart? It's in the upper right corner. It should be the second formula down. Cosine times a sine. I'm going to write the formula over here to the left. It's 1/2. I don't like this background. I will not use the colored background again. 1/2 times sine A plus B minus sine A minus B, and that equals cosine A sine B. So that's our generic formula, and the reason that I wrote it this way is so we can easily see what I'm going to replace for A. Oops, we could before I highlighted it, and what we're going to replace for B. So A we're going to replace with 2x, and B we're going to replace with 5x. Okay, so let's go through our problem, and wherever I see an A, I'm going to put in a 2x. Wherever I see a B, I'm going to put a 5x. Everybody okay plugging in your 2x and your 5x? Pretty simple. Okay, so now we're going to simplify. So I'm going to combine some like terms. My 2x and 5x is going to become a 7x. And over here, my 2x minus 5x is going to be a negative 3x. Okay, now the online lesson, again, did not do such a good job of explaining these, but sine is considered to be an odd function. Cosine is considered to be an even function. So what that means is, for cosine, if you get a negative, it's as if it's counting twice because it's an even function. So a negative times a negative makes it a positive. Sine is considered an odd function, meaning if you see one negative, that means it's going to stay a negative, in other words. I'll show you an example in just a minute, because that's not a very good explanation right there. So what we do is, if it's a sine, that means this negative stays. Stay is the wrong word. I'll show you an example of a cosine in just a minute, and then it will make more sense. So this negative doesn't automatically turn to a positive. It means I have to take this negative and add it to the front. Because there is already a negative there, I'm going to get a positive sine 3x. And this would be your final answer. I'm going to show you how cosine is different. Let me make some space for myself. Here's the difference between the two. So if at that stage I ended up with a cosine, let's say I had this, cosine of negative 3x. Cosine is considered an even function. Even functions automatically become positive. So for me to rewrite this, this negative, since it's a cosine, would automatically become a positive. But that would still be there. That's the difference between sine and cosine. So cosine, again, is even. It automatically becomes a positive. Sine is odd. Odd means it stays a negative, but where we take that negative is we stick it out in front. So the two negatives in this case became a positive. That's a huge difference between sine and cosine. So go ahead and add that to your notes. Whoa. So sine is an odd function, meaning it stays negative. Cosine is an even function, which means it becomes a positive. So just make that little note of that. You won't have very many of those, but I just wanted you to understand why this negative got to stay, so it goes out in front, became a positive. If it was a cosine, that automatically becomes a positive because it's considered an even function. Okay, did we get that added to our notes? That's kind of the one tricky spot that I found for 4.2 was keeping track of those two at the very, very end of your problem. And that's as far as we can simplify. That's how they kept their final answer. All right, I don't know why that was in there on the very last slide. That's very interesting, in the wrong spot. So for our week 12 essential question, again, it should be very easy for you guys to answer. When looking at the right and left side of a problem, how do you pick which side of the problem to start solving when dealing with an identity? So that's all I'm looking for week 12. And then I was going to talk to you guys about 4.3 because we're already at the 37-minute mark, and I knew that this would be too much information at one time. So what I'm going to do for you is I'm going to create an optional recording for you to watch for 4.3. I am going to make it 5 points of extra credit, so that way if you want to do it, awesome. If you don't need it, that's awesome too. I'm not offended either way, but you'll have it before your test. Does that sound good? So 4.3, I'm going to make an optional recording so that way I can cover some of those topics with you. I'm going to make an optional recording. It will be worth 5 points extra credit. Yes, I'll make a separate Dropbox for that, and I will have it posted by tomorrow afternoonish. Because here's what I'd like you to do. If you have certain things on the 4.3 checkup that you need help with, send me a K-mail with the question numbers, and I will add those to the recording. So that way I can solve some of them with you guys. Does that make sense? So 4.3, I'm creating an optional recording. It'll be worth 5 points extra credit, not mandatory, and it's going to be help with the checkup. So if you have any questions on the checkup that you don't understand, send me a K-mail with the question numbers. So I'll need that by the end of today. So if you can look over 4.3 and say, oh my gosh, I'm really stuck on number 7, just let me know and then I can include number 7 in my recording for you guys. Sound good? Because we just didn't have time today to do 4.2 and 4.3. All right, well thank you. Have a fabulous day and I will see you guys next week.